Kia ora, Year 12. This is what I think is quite a tricky DE question from the March 2017 paper, and it's one of the ones I gave out in class on Thursday. So we're just going to read through it first and see what we're being asked to do. It's got two parts, and I think in some ways this first part is the tricky bit. The good thing about that is that even if you get stuck on it, then you can still get it done. Just trying to get my stylus to work. Yep, there we go. Okay, so this 3 marks is quite involved. We've got a water tank with vertical sides and a horizontal rectangular base, and the area of the base is 2 meters squared. So straight away, we can say that the volume of the water in the tank is going to equal the area of that base times the height. So V will equal 2H, and we're going to use that later on. So at time t equals 0, the tank is empty. So t equals 0 gives us V equals 0. And water begins to flow into it at a rate of 1 meter cubed per hour, and at the same time it flows out from the base at this rate. So we can put those inflows and outflows together. This is not too bad. We can write that dV by dt is equal to 1 minus 0.2 h to the power of a half. And then we're asked to form a differential equation satisfied by h and t, and to show that the time taken for the depth of the water, which is h, to reach 4 meters is given by this thing here. In other words, what we need to work with is dH by dt. So this is how I thought about it. You could have done it some different ways, but I looked at dV by dt and said that by the chain rule, that's equal to dV by dH times dH by dt. And we know this one, and we know this one. So we're going to get an expression for dH by dt, and then we're going to solve the differential equation. And we're interested in how long it takes for the h value, for h to get to 4. Right, so dV by dt is equal to 1 minus 0.2 root h, and that equals 2 times dH by dt. That gives us dH by dt is equal to 1/2 minus 1/10 h to the power of a half, which is equal to 5 minus root h on 10. So h, sorry, what am I doing? Separating the variables, we get this. And now I can integrate both sides with respect to that. And I'm going to put limits on of 4 and 0 because I want to figure out when it takes to get the water to be 4. So here we've got, on this side we've got t, and on this side we've got the definite integral 10 over 5 minus root h. Now this is t because this is equal to the integral of 1 dt. Okay, so actually that's not too bad, and that's 3 marks. So the time that we need to get from 0 to 4 meters is given by this. In the second part, we have to solve that equation, and we're told to use this substitution to find how long it takes. Okay, so what we need to do is to take everything in here and switch it over to u. So I've left that dH out there. We're told to use the substitution that u is equal to 5 minus h to the power of a half. That means that du by dH is equal to -1/2 h to the -1/2. So du is equal to -1/2 h to the -1/2. Now looking at what we're going to have to switch out in here, we can easily replace this with u, but we're going to have to get an expression for dH. And I've just managed to leave the dH off there. There we go. So it's not quite right. We need to have a way to get rid of dH. So we're going to move all of this to the left-hand side by multiplying or dividing it. we get 2 negative 2 root h du is equal to dh. This is not very good because we don't want to have any h's in here. What we're trying to do is to switch out that dh completely in terms of u. So if we go back up to this, we need to rewrite that expression so that we can substitute this. So we get h to the power of a half is equal to 5 minus u. And now we can take this and replace this in here. So we get negative 2 times 5 minus u du is equal to dh. What we need to do when we're looking at a question like this, oops, okay, weird thing just happened. There's some magic pixel, and when I touch it, OneNote shuts down, which is pretty annoying. But going back to my integral, we're now going to be able to substitute this out, and we can do this one. And the last thing we've got to do is work with our limits. So my h limits are 0 and 4, but u is equal to 5 minus root h. So 5 minus 0 is 5, and 5 minus root 4 is 3. So what we can say now, and I'm going very slowly with this video on purpose, right? So we've got this. The limits change over to be 3 and 5. And then I've got 10 sitting here, and instead of 5 minus h, we've got u, and instead of dh, we've got negative 2 times 5 minus u du. That gives me negative 20 out here times the integral of 5 minus u over u du. Now, if you remember from AS, the integral of BA, f of x dx, is equal to the negative when I swap the limits over. So I'm going to do that here. I could work with it through with the limits like that, but for me it just feels so strange having the bottom limit be above the top limit. So this is equal to 20 times this. And I'm also going to split this up as follows. And you can see it's got much, much easier to work out that integral now. So we've got 20 times 5 natural log of u minus u evaluated at 5 and 3. And that gives me 20 times 5 log of 5 minus 5 log 3 plus 3, which is equal to 20 times 0.5541, giving me an answer of 11.08 hours. Or if you want to put that into hours and minutes, it's about 11 hours and 5 minutes. So there you go. Let me know if you've got any questions on any individual steps in there. There's a lot of good stuff going on in this question. One of the things that I think is most worth going over is this step in here where the switch between dh and du requires just a little bit of extra changing around, right? So we've often had the case where we do our u equals blah blah, but sometimes we need to be able to make something else the subject, right? So we need to here work backwards to get what h is in terms of u.